Hello, and welcome to this edition of the Pulse on Power Show. I'm Ed Merkel, and we are pleased to present to you this series of videos designed to demonstrate the key features that you should be considering when selecting a power supply. Today's video will focus on the importance of a fold-forward versus a hiccup mode overload design and the impact it can have on the sizing and the cost of your power supply and control system. There are two types of switch mode power supplies, hiccup and fold-forward. And this presentation will explain why the fold forward is so much better in almost every application. This is the graph of our 2.1 amp fold forward design power supply. You can see that at no current, the output is 24 volts DC and remains steady until the current reaches 2.1 amps. Any current after 2.1 amps causes the power supply to go into overload, which also causes the output voltage to drop, but the overall output wattage is maintained. For example, if the current increases to 2.3 amps, the output voltage will drop to approximately 22.5 volts DC, which for the typical load is still enough voltage to operate for a short period of time. So during an overload situation, constant power is maintained with no shutdown of the power supply. With the hiccup mode power supply, an overload is not handled in the same manner. Once again, the voltage would be 24 volts DC at zero current, and as the current increases above its rated value, the power supply will shut down, wait a small period of time, and then attempt to start again. When the power supply attempts to restart, the overload current is not changed, so the unit will shut down again. This process will continue until the current is reduced below the rated value of the power supply. If the current on startup is also too high, then the power supply will not start the load. Let's take a look at a working example of both types of overload design. The panel on the left is the Poles 24 volt DC 2.1 amp or 50 watt power supply, and the equivalent rated brand X power supply is on the right. These panels are wired and loaded the same. This is a very simple wiring configuration with 120 volt AC power coming in the bottom and the DC output power coming out the top. The load is two 25 watt 12 volt DC light bulbs put in series, which equates to a 24 volt DC 50 watt load. When we energize the unit, the light bulbs turn on as expected. The DC OK LED on the front of the power supply indicates that the power supply is functioning within the normal output voltage range. If we clamp on the ammeter, we see that the current is at or within the rated current of the supply. If we energize the hiccup mode power supply, you will see that the lights do not turn on, which would make it seem that one of the light bulbs is burned out or there is a problem with the wiring, but this is not the case. If we look closely at the LEDs, you will see that the DC low light is flashing, indicating that the load is too much for the power supply to start. If I unscrew one of the bulbs, essentially removing the load from the power supply, you will see that the hiccuping stops and we get an indication of the DC voltage being good, which tells us that we have a functioning power supply. However, once the bulb is screwed back in, the unit hiccups once again, and this process will continue until the load changes. But since these light bulbs represent a resistive and not a dynamic load, the current will not change, and so the lights will never turn on. Because this 50 watt power supply was unsuccessful in starting the load, a larger unit would have to be installed. This is one of many reasons why users oversize their power supplies. However, when using poles, oversizing is not necessary, which can save you money not only on the supply itself, but possibly by utilizing a smaller enclosure. To better show the power behind the poles overload design, we can show this same demonstration utilizing a Poles 30 watt supply. When I plug the unit in, you see that the Poles 30 watt power supply has enough overload capabilities to energize the 50 watt load, and if you look at the DC OK LED, you will notice that the power supply is still operating within the proper DC output range. Poles does not recommend utilizing a power supply in this manner, but it does dramatically illustrate the difference between the brand X 50 watt power supply, which was unsuccessful in starting the same load. Choosing a Poles power supply that is rated for your application's nominal current will give you the power you need to start those loads without oversizing. Thank you for joining us. If you have any additional questions, please call us or refer to our website where we have additional information on our products and applications. All of us at Poles thank you for joining us today, and we look forward to seeing you on our next edition of Pulse on Power.